Hi guys, welcome to your next homework assignment. I am at the gym, so you might hear some funky noises behind me, but that is okay. All right, so this is homework 3.04. We're going to go through all of the odds. Okay, first thing, evaluating this little thing. This guy is sigma. What he means is it's the summation. So what you're supposed to do when you see that guy is you're supposed to add. So this is saying we're going to start at 1 and go to 5, and we're going to add all of those evaluated in this expression. Okay? So first thing, we're going to plug in 1. We're going to go 1 minus 7, and that gives me negative 6. Then we're going to go 2 minus 7, and that gives me negative 5. 3 minus 7 gives me negative 4. 4 minus 7 gives me negative 3. And then lastly, 5 minus 7 gives me negative 2. And I know that's where I'm supposed to end because the top value tells me end at 5. Okay? So now, because we have the sigma, we're going to add all of those together. So I'm just going to go left to right. Here we'll have negative 11. Here we'll have negative 15, negative 18, and negative 20. So our final answer is going to be negative 20. And we're right! Yay! So that's the idea for the first part. Remember, we're doing odds, and you're doing odds too. So now I'm going to use this expression, and I'm going to plug in all of the numbers from 2 to 4, and then I'm going to add them together. So 2 squared minus 2, 3 squared minus 2, and then 4 squared minus 2. 2 squared is 4, 4 minus 2 is 2. 3 squared is 9, 9 minus 2 is 7. 4 squared is 16, 16 minus 2 is 14. So then we're going to add 7 plus 2 gives me 9, plus 14 gives me 23. So we're going to plug that in. Oops, not 03. And we're right, yay! Cruising right along here, friends. Okay, so now they want us to create a series, okay? Let the sum start at 1. Where does the summation end? So what's weird is this talks about position. This means you plugged in 1, and if this is the resulting series, that means you ended up with 4. So there are 4 terms in the series, so that means that this ending number has to be 4. So we're plugging in 4. Yay! So now they want to know what is the general term for the summation. Now I'm going to say for this series, this is definitely geometric because see how fast it goes up? And remember, geometric, you start with your first term. It's called a sub 1, that first term. And then we multiply by how the numbers are changing, raised to the power of the number you plug in minus 1. So our first term in this one is 4. Our common ratio, how the numbers are changing, it looks like we're multiplying by 3. 36 times 3. 6 times 3 is 18. 9, 10. Yeah, we're multiplying by 3. So the common ratio is 3. And instead of n minus 1, we're going to put I minus 1. Just because summation notation uses I. So we need the little dots. Remember that mistake we made last time? We're not going to make that mistake. I minus 1. Let's check if we're right. We're right! Yay! So you're using the same formulas as before, okay? And if you forgot what they are, just look it up in Google or go back to the other video. A gardener is making a triangular planting, that's weird, with one tree in the first row. I'm going to draw this out. One tree in the first row. There's 3 trees in the second row, 5 trees in the third row, and so on for 5 rows. So 1 row, 2 row, 3 rows, 4 rows, 5 rows. Write a sequence that describes the number of trees in each row. Find the total number of trees planted. So this tree sequence, okay, it looks like it's going to be an arithmetic sequence because it's not going up super big. Okay? So, and it looks like every time we're adding 2. Every time we're adding 2. So for this sequence, we're going to start with our sigma notation. And, oh, they want the first sequence here. That's what they want. Okay, so if we're adding 2 every time, 5, 7, and 9. So they just want us to list what it is. It's going up by 2 every time. 1, 3, 5, 7, 9. Yay! Okay, and then the total number. Oh, okay. This one, we don't have to come up with a formula for it. They just want us to add them all together. So 9 plus 7, that's going to give me 16 plus 5. 6 plus 5 is 11. 21 plus 3 is 24. So there's 25 trees after you add all of those together. So this is just dealing with, okay, so now we're talking about partial sums. So we'll definitely have to look up a formula here. So use the partial sum formula to find the partial sum of the given sequence. So for here, I'm actually going to refer to our help menu. I'm going to go to view an example. So here's the partial sum formula. I'm going to write it down. So the partial sum of n numbers of a sequence is where you take the first term of the sequence, you multiply by 1 minus the common ratio raised to that number's power all over 1 minus the ratio. That's what we're doing. Okay, so in this one, we want the sum of the first 4 terms. So we would be looking for the sum of the first 4 terms. The first number in my sequence is 5. My common ratio is how the numbers are changing, and if we look at the numbers, it looks like they're going up rather quickly. It looks like we're multiplying by 3. And it tells us geometric, so we know that it's multiplying. Okay, so this is a 3, and we're raising it to the 4th power because we want to find the sum of the first 4 terms. 1 minus that common ratio. So then 3 to the 4th power is 3 times 3 times 3 times 3. That's going to give me 9 times 3 is 27 times 3. 7 times 3 is 21. 2, 81. So 5 minus, this is 81. 1 minus 81 is going to be negative 80. Times 5 is going to be negative 8 times 5 is 40, so I just add another 0. 1 minus 3 is negative 2. And 400 divided by 2 is going to be the same as 4 divided by 2, and you add those 2 zeros. So this would be 200 because the negatives cancel out. And again, if that's not your strong point in figuring out that stuff with order of operations, use Desmos. Desmos is amazing. Okay, I'm going to erase all this stuff. I think we're going to be running out of time here soon with my video, but we'll see.